Alright, back at the bench again, doing several videos here in the last few days, and I figured I'd come back to, where the heck is it, this Z80 test adapter here. So I'm actually going to see if I can take this off real quick and start from scratch for you guys. So, dang, the thing's in there good. There we go. Okay. So anyway, this is the I'm going to take the Z80 out real quick too. It's a, on the previous video, now I can't even remember where I got it from. Low-tech Z80 CPU test adapter, and basically it disconnects the data pins from the board under test. And so I actually had picked up a bunch of boards recently, and can you see that? Okay, yeah. This is like a Yogi. This is a parts board, and I picked it up and it had a Z80 in it. And to obviously test this, I need a board that's going to provide clock and 5 volts to test the Z80 with the signature analyzer. This is the Kurtz Cache signature 2, but you could use I think there's a HP one that as well that should work as well. So the first thing I did is I looked at this board and I was like, wow, I have no idea how this board works or if it's working at all. But really all I need is the clock to work and 5 volts. So I have my 5-volt power supply over here. You can't really see it that well, but it's all jerry-rigged and everything. And so what I did is take my adapter and plug it into this Z80 socket on the board under test. And we made this adapter in a previous video, and thanks for, now I can't remember the guy's name, but on Clove gave me this resistor network here, and that's how it's supposed to be. And actually I might replace these header pins too with jumper style pins, because I have some of those now that I can use. So anyway, so I was like, okay, well, let's figure out what's 5 volts. And so I used my multimeter here. Oh, why is that weird? Okay, turn on the light, and I basically took, it's all labeled on this adapter where ground is and where VCC is. So I just basically took VCC, and usually the 5 volts is going to come off of a capacitor somewhere. Whoa, what's going on with my meter? I wonder if it's low on battery or something. Okay, so let's see if, there we go. Hopefully you guys can see that okay. Yeah, so anyway, so I basically, come here to our volt CC, and then I was probing all around and looking at different caps and where power might be. I was coming over here and wouldn't get anything. So I knew that wasn't tied to 5 volts. And then I came to this capacitor here, and I had continuity on that side and not on this side. And then I went to my ground pin, which is, I don't know, pin 20 something probably. And I have ground there. So I knew on both sides of this capacitor I could hook up my negative and positive and get 5 volts. So I took my power supply like this, and this was negative, I think. Let me double check that now. Yep, okay, that's negative. And then I had this is my +5. See how we can get in here. Kind of tight because these other capacitors and stuff. There we go. Alright, keep that out of the way. So now I can actually plug in and get power to it. And we have a Z80 that we want to test. So we're going to put that in the socket as well. Into the test socket. Just like that. And let's see, I think that's pretty much it. And then we, on the signature 2, we fire this thing up, and it basically, they have instructions on how you're supposed to hook up, where you're supposed to hook up your start and stop, and your clock, and your there is no, on mine I don't have a voltage reference of, for the 5 volts. For TTL logic, I read the book before, it says you don't really need to use this. It uses the 5 volt power supply in the Kurtz cache for the voltage reference. For CMOS chips, I think to test CMOS type style things, I guess you're supposed to use the V voltage reference, but there is no wire on mine for that. And then we obviously have ground for that. So let's look at our Z80 here somewhere. I mean, this is kind of, can you see this? Not really. Let me grab this. Let's see if you can see that somewhat decently right there. Yeah, so basically the start and stop, I think it's 15 clock pulses or something like that. So you have the start and stop on the, what they say is the highest order address line, I'm pretty sure. Yeah. And then basically it, the way it generates a signature is that it's sending a certain amount of data, consistently, and always starting and stopping at the 16th, I think 16 bits, and it compresses them anyway. You can read the book. I barely understand it myself, so, but it does work. So kind of fun to read the stuff. But the more you read, sometimes the more you get confused, and then eventually you start experimenting with it, and then it starts to make a little bit more sense, but not enough for me to actually explain it intuitively to you guys. Let's see here. Okay, cool. So yeah, it tells us on this page right here where we want to set up our start and stop. So we want to start on a Z80, we want our clock on pin 21 and our start and stop on pin 5 and ground on pin 29. So that's cool. Let's do that. So pin 5 is our start and stop, which is going to be our yellow and our blue. And we're going to see the best way to do this, kind of in a little bit of a small area. So this is 1, 2, 3, 4, 5. I'm pretty sure that's address line 15, yep. And that's the highest address line. So we do it that, or both yellow and blue there. We put our clock on pin 21. that should be, it's a 40 pin socket, so that should be pin, this first one up here, and that's address line 10 actually. Yeah, there's got to be 1, 2, 3, 4. Anyway, I'm pretty sure that's right. We'll know here in a second. And then our ground goes on pin 29, so 22, 23, 24, 25, 26, 27, 28. Oh crap, hold on. No, that's wrong. I'm counting wrong. So pin 21 is going to be way down here for our clock. Counted the wrong direction. And then pin 29, so if that's 21, 22, 23, 24, 25, 26, 27, 29. Yep, and that says ground on it, so we know that's right. Helps to have these untangled a little bit. Okay, so we should be good to go there. Now all we need to do is power it up. Alright, cool. And you can, hopefully you can, yeah, you can see that on the signature too. So when the gate is flashing, that's good. When that gate LED is flashing, let me see, I'll read the actual, what it's telling you. So we can self-test the signature 2 analyzer. It says to self-test, connect clock, start, stop, ground to proper places on logic board to be tested. The gate LED must be on. So the gate LED is flashing. Touch the data probe to ground. The signature 2 should read all zeros. Alright. So here's our probe is, what happened to my probe? So if we touch it to ground, and on this probe, by the way, there's latch and pulse, and I haven't quite figured that out. I want pulse because I think that means this middle light will pulse as we have transitions from 0 to 1 or high to low. I think that's what that means. This also has its, they describe it in the book, but a single threshold needs to be crossed or both thresholds need to be crossed. So I might have a diagram, I'll come back to that, but basically when you have the dual threshold, to actually get a 1 or a 0, it has to go above the threshold where it goes out of the 0 range and then go into the threshold of where it goes into a 1 range before it will transition to one or the other. So it kind of prevents oscillating back and forth when you have logic values, I guess, or voltage values that are real close to the range. Probably not describing that very well, but anyway. So if we touch this to ground, we got 0 plus 0 is 0, okay? And then if we touch it to volt CC, which is our positive, we get 0, 1, which is what we should have on a Z80. And let's see. And as you're touching it to VCC, if I press the test button, I should get all U's. And I get that as well. So I know my I know that my signature 2 is working correctly. Alright. And let's see here. And go back to our Z80 processing thing. You can download this manual, by the way. It's pretty useful for other things as well. So basically what we want to do is we want to start probing the address lines and seeing what the readings we're getting here. So if we get all of these signatures here, then we know, I assume that our, excuse me, the Z80 is okay. So we want to start with, yeah, it's hard for me to actually see this board. Probably need to jack this up here real quick. How do I do that? I'll be right back. Okay, I just placed my multimeter under it so it could get a little bit better angle. Hopefully you guys can see this. So it's saying probe address line 0, A0, and then we should be able to see a signature of UUU. So that's right there. And we see UUU on our signature analyzer. So we know that's good. And we keep going. A1 is 555. And as you see, when I first touch it to the address line that we're measuring a signature on, it will flash invalid for a split second, probably because it's like catching a signature like mid 16-bit counter is what I would assume, something like that. And then as you hold it there, obviously the signature, is reading the 16 bits, I guess, and compressing it or whatever, and then generating the signature there. So okay, what am I measuring here? A3. Okay, A2 should be CCC, and it is. Then A3 7FF, which is correct. Then 5H21, that's right. OAFA is correct. UPFH, that's right, for address line 6. Address line 7, 5258. Oh crap. HC89. Yep, address line 8, there we go. 2H70, that's correct. HPP0, that's A10, that's correct. Then we come down here to go to A11, 1293, HAP7, 3796, that's address line 13. And you look at the activity lights, can you see that? Yeah, you can see that. Okay, cool. This, because as you're going up, like when you start here, it's kind of like address line 1. When you have the NoOP adapter, I guess it's like sending like a single bit, and then it increases by a factor of 2, I think, each time you move up. So it's like gets faster and faster and faster. But this signature, and if I could put this on my oscilloscope and probably show something very similar. 3827, and then 75 pp, and if on the 5 volts or VCC we should have 001, which is true. This is all for the Z80. So we basically tested the Z80, and I pulled the Z80 actually from an unknown working board, so it passes the signature analysis. So I don't know if that's 100% way to measure a Z80 or test a Z80, but it looks like it's right to me. So and I would assume that this Z80 is correct. So I think that's about all I wanted to show. Let me see if there's something else in the book that I can show about the signature 2 Kurzcast. There is this glitch function that I haven't quite figured out, but usually when you're reading a signature, if you want to throw a random false bit to make the signature invalid, you use this glitch. There you go, see? You use that glitch tool to kind of throw like a random, bad bit into the pattern, I guess, or something. I'm probably, again, forgive me for all my bad terminology, but it kind of, gives you, I don't know, it worked last time. Makes the signature invalid somehow. Anyway, I'll pause for a second and see if there's anything else that I wanted to show on this quick video. But now that I know I can test the Z80 and I know that my signature 2 is working correctly, I feel confident that I can start maybe using signature analysis to test some boards. Okay, so there are excuse me, there are a few things that I wanted to mention real quick. So rather than read how signature analysis works and stuff, I mean, like I said before, it creates a window to measure the clock pulses, and then it has some data compression circuits that compress the data into like 4-bit words or hexadecimal words. And the only thing is because this is kind of a simple LED style old school output, I think that's why they have a modified hexadecimal words. So you have 0 through 9 like you normally would have, and then A but no B, probably because B would look like 8 on this LED. And then you have C, F, no G, H, P, and U. So most likely they chose those is because you could make sure that you could display letters in this simple LED format. So that's one thing I want to mention. It's not simple, or it's not true hex that they're displaying there. And let's see if there's the other thing I wanted to mention. There's also the you have two types of counters, I guess, that you measure with signature analysis. One's an asynchronous counter and one's a synchronous counter. And what we did when we leveraged this adapter, it's a no operation data instruction set. It basically, if you can see here on the, can you see that now? Right there, maybe? Anyway, you're basically grounding all the data lines, or tying all the ground lines to all the data lines to ground, and that's what our resistor network here, RN1, did. Is it basically took, in this no operation adapter, basically untied the data lines from the board under test, and then held all of them low, and that's what causes the CPU processor to become and act like a synchronous counter. So you can measure it, just like you would a regular TTL type of chip that was synchronous. And let's see if there's some other interesting thing I want to mention. It does show in here as well that how you're supposed to actually grab clock from the different CPUs. And we're looking at the Z80, and it says use pin 21 RD, leading edge for clock, and start and stop trailing edge for addresses. So what that means is, if I put my book back down, is on this is this the, yeah, this is the control probe, I guess is what they call it. Whoops, my yellow came off. Yellow is my start and stop. Put my start and stop back on. Darn it. All right. Let's see if you can see that. Yeah, I think you can. So there's a little, Z, it's basically a Z, which is the leading edge indicator. And then on the right-hand side, where it's more like an S, is the trailing edge indicator. So it said that for the Z80 test, we wanted our clock on leading edge and our start and stop on trailing edge. Now, I haven't quite understood how I'm going to be able to determine when to do what without just looking at a book that tell you that. So hopefully I'll learn more about when to use leading edge and trailing edge and all that stuff a little bit later. But we actually had it configured incorrectly. We had, when I just did the test, we had them all on trailing edge. So I just want to check and make sure our signatures are all the same. And it's not, which is kind of weird, right? Let's test it to ground. See, I'm not getting any signatures now, so let me power this off. And my gate's not actually on either. Okay. Alright, now let me pause, and something obviously happened between me reading that book. Maybe my 5 volts is off or something. Okay, I'm back. You can see where the when I was having the trouble, and I just basically powered everything down and powered it back up, but I don't know if it was the board or what, but I definitely wasn't getting good clock start and stop, and that's what this gate LED is for. It should definitely, see here, it says there's a couple circuits that are interesting. One is the gate circuit LED right there indicates that clock and start and stop pulses are valid. So we weren't getting either good clock, I don't know, maybe it was from this board, you know what I mean? I had it powered on for a while, and then, you know, obviously it's a junk board anyway, so, but now I powered everything down and powered it back up, and we can see that our gate is good. And I did change my control probe to be clock, or the white cable to be on leading edge, and see if I can get, and my signatures are the same, they're still valid, so I have no idea. I'm not quite sure I understand the significance, you know, of when I should be starting my count on the, you know, on the leading